Hey, do you think we should know about as much about our software as we do what's in a Twinkie? Tune in and hear about software bill of materials with me, Alan Friedman.
Hello, everybody. Welcome back to Firewalls Don't Stop Dragons. I'm your host, Kerry Parker, and today we have episode 229 for July 19th, 2021. Now, one key thing to note is that I recorded this almost 2 weeks ago, because right now, as you are listening to this, I and my two daughters are basking in Hawaii. I've been trying to get to Hawaii for many, many years, and I'm happy that I'm finally there. Hopefully, no volcanoes explode or anything while we're there. But we were actually supposed to go last year. My daughter graduated high school, and that was going to be her big graduation gift. But of course, COVID hit. So anyway, we had to delay it, but now we are there. And normally, I would advise people not to broadcast their vacation plans until they return, because that just tells the bad guys when you're not home. But I have my house being watched by a house sitter, so it doesn't really matter. So the upshot is, if there's been any huge stories between the time I recorded this and the time you're hearing it, that is why I'm not mentioning it now. Actually, we've got a long interview today, so I'm not going to have much more in the way of introduction before we get into that. A couple things I want to define before we get in there. We throw two terms around I think I caught that we didn't really define. One of them is JSON. That's spelled JSON. That stands for JavaScript Object Notation, which is just a fancy name for a particular kind of web data file. Most of web pages today run on JavaScript, and JavaScript has this tidy little key value format for files that it can use to pass a lot of data around. So in today's context, it's a way to format a bunch of data for a software bill of materials, which my guest Alan Friedman will discuss here shortly. The other thing that was mentioned real briefly was SaaS, or SaaS, or software as a service. It's a industry marketing buzzword that basically means a cloud app, like Google Docs or maybe even Spotify. The real processing, the real stuff happening is being done in some cloud service somewhere up in the internet, and you've got a web browser that's just kind of accessing that like a client. But it's kind of the difference today between software that you're actually running locally on your PC or your Mac, or often, you're getting to something via a web browser, which really means a lot of cases that software is running on some server up in the cloud, up in the internet somewhere, and you're just kind of looking at it. So with those two things defined, let's get into our interview with Allan Friedman, and we're going to be talking today about a software bill of materials, or an SBOM. And while it sounds simple, it might even sound boring, it's really important and something sorely missing from our software industry today that would make a huge difference in security and even privacy. And he's pushing to have the software industry adopt these practices so that we can all be safer. So let's not waste any more time. Let's get to the interview with Allan Friedman. Allan Friedman is the Director of Cybersecurity Initiatives at the National Telecommunications Administration, which is part of the U.S. Department of Commerce. There he coordinates cross-sector efforts to address key challenges in the cybersecurity ecosystem. Welcome to the show, Allan.
Thanks for having me.
And, as I say that, I think I just realized that you're the first government employee I've ever interviewed, which now that I've said that makes me realize I've done it wrong. I need to do more of that.
In the cybersecurity world, we just shout "Fed" at each other really loudly.
Right. Well, I definitely need to get more feds. Maybe you can hook me up. Let's start off. So just tell us a little bit about, more about yourself and your organization. What is it you guys do, and how long have you guys been doing it?
Sure. So I joined government about 6 years ago after spending some time in the cybersecurity academic world, universities and think tanks. And a lot of my focus from a research perspective was, we talk about a market failure in cybersecurity, that the market isn't providing the right amount of security. And at the Department of Commerce, one of the things we try to do is to say, how can the US government help catalyze better markets? So rather than dictating this must be the solution, saying, hey, let's bring together the right people to find the approach. And so at NTIA, we try to identify specific types of problems where we say, if we bring the right people, the government doesn't care what the solution is. We just need a solution to exist. This would bring the folks together.
Yeah, and that is a wonderful way. I know a lot of people, think of regulation and they think, ugh, no, immediately turns them off. And so there are, it's like, kind of like the executive order from the Biden folks, or from the Biden administration, where it uses the government's purchasing power to kind of put a lever on the market, but without actually straight up regulations. I mean, there's a lot of, areas where the government can influence things without necessarily dictating them. So that's awesome. Today, we're going to talk about something that sounds extremely mundane, I think, at first blush, but it could be really, truly transformational for the software industry and, the overall state of cybersecurity and even privacy. So let's start with the basics. What is it your team is trying to do exactly?
So we are trying to advance the idea of what is called a software bill of materials, or SBOM. So we're going to talk a lot about SBOMs today, software bill of materials. So what is an SBOM? The easiest way to think about it is a list of ingredients for software. So if I go to the store and I buy a Twinkie, it's going to come with a list of ingredients. And it will be up to me to look at that list of ingredients and say, yeah, this is okay, this is fine. So for example, Twinkies have tallow in them.
Oh my.
Which is a form of beef fat. Now, my risk calculation says if I'm willing to put the rest of the things in that list of ingredients into my body, the beef fat doesn't really bother me. But we all know someone for whom that would be an issue.
Yeah, right.
They have a dietary restriction, they have a belief system, and so they want to make that decision. And a list of ingredients model allows us to make those risk-based decisions without saying you can't do something, right? We're still allowed to sell Twinkies and buy Twinkies. But everyone can now say, yes, this meets my standard or this doesn't meet my standard. And it's not unique to food. If you think about economics, a classic tenet of the free market is that we have shared information, that we know what we're engaging in. There are other areas we see this. So for example, in the chemical industry, we have the idea of a safety data sheet where if I get a tractor load of 50-gallon drums onto my factory floor, they're each going to come with the safety data sheet that says what's in this barrel and what do we do if one of them spills all over Susan. And we have that plan. And in fact, the term bill of materials comes from supply chain in industry, classic 20th century industry, first pioneered by a guy named Deming, who was instrumental in creating how folks like Toyota think about supply chain, where if I'm going to buy a super expensive generator for my hospital, it's going to come with a list of every nut and every bolt so that I know what the total cost of ownership for the next 50 years of that generator is. And so I can do maintenance on it, right? But that generator today is probably going to be connected to the internet. And what we want is to say, hey, the software that's running, what's the cost of ownership and maintenance for that? And to do that, we need to say, is the ingredients that's used in that software, is it fresh and healthy, or is it past due? Is it potentially putting my organization at risk?
Yeah, so you mentioned Deming, which, back in the car industry was a big deal. He was like the name, like all the business books quoted Deming. And so, you're right. Manufactured products would probably have that notion for a long time. And again, it seems mundane. A lot of people probably don't give it a second thought, but for people in the industry, it's a really big deal. I mean, just, having a handle on what goes into your products and, to help you manage your inventories and organize your supply chains like you talk about. So did you look at that history? Did you kind of compare, or when you were kind of thinking about how you might want to structure the idea of an SBOM, or maybe as you're trying to sell its benefits to the companies that you're trying to prod into using it, did you kind of look back at the history of hardware bombs? H-bombs, I guess that doesn't sound that good. I'll talk about computer hardware in a minute, but did that inform how you went about proposing what an SBOM would be?
It's definitely something that's informed the thinking around this. And I also want to be clear that, NTIA did not invent this idea of an SBOM. It's an idea that's been around, that people have been talking about for a while. It was even proposed in legislation back in 2014 by the U.S. Congress. That met with some pretty stiff opposition, but we've seen it crop up in other places. So, for example, in 2015 or 2016, there was a congressional task force looking at cybersecurity in the healthcare sector.
Mm-hmm.
And this is something that sort of pulled forward and said, hey, we should have SBOMs in the healthcare sector in particular. And a lot of the thinking behind this was informed by supply chain responsiveness. And one of the ideas that's come out is Deming said, hey, part of why you need to know what's in your products is because you want to have the best possible suppliers. You want to care about the quality of it. And so that gets to how transparency in the software world can help us, because people are starting to pay attention and say, hey, where is this software coming from? Is the supplier trustworthy?
Right. And the supply chain thing should raise the hairs on the back of people's necks, because that was the basic problem with the SolarWinds attack. There was software used by many companies and government organizations that at its core used this software built by this one company that had a horrible bug in it, right?
And I think right there's a class, different types of attacks into the software supply chain are going to require different types of solutions. This has been something that we've seen over the past few years increasingly common. And some of them are almost comical. So for example, back in 2019, someone created a whole bunch of fake software components that had popular names, used something called typo squatting, where they named them similar to what people were using, and tricked a bunch of people through a variety of means to download this. And they put backdoors in these softwares so they would do malicious things. Someone went through a lot of effort. What did they do? What was the evil plan that they had? Well, it was to engage in fraud for auctions for sneakers.
Right.
Now, you and I may chuckle at that because, we may be vaguely aware that there are people who spend hundreds and even thousands of dollars on sneakers. There's big money in it, worth committing online fraud for. But if someone wanted to do that with something much more malicious, they could have real consequences. And we've discovered that over the last year or so, as there have been more high stakes attacks, including against very important government targets. Now, the important thing to know is that there isn't going to be a single one-size-fits-all. You mentioned the administration's executive order on cybersecurity recently, which sort of is trying to lay a foundation to get us there. But there isn't going to be one approach. What having a software bill of materials gets you is it gets you resilience. It gets you the ability to say, once I know that there is badness in my supply chain, everyone can now ask, am I affected? Is this something that's on my network? And today, that's very hard, especially when the badness isn't just it's made by this popular company. It's made by Microsoft. It's made by Cisco. But if the badness is someone compromised one of the ingredients, then we need to track that. And that's really what SBOM allows us to do.
Yeah, and I think a lot of people that are outside the software industry don't think of it that way. They think of it as sort of, well, I bought Microsoft Word or I bought Adobe Illustrator or whatever, and they think, well, Adobe made that, right? It came from Adobe. But like a car, you may buy a Ford, but it's made up of thousands and thousands of parts that were not made by Ford. It was assembled by Ford, and maybe a couple of those things were made directly by Ford. But yeah, software today is the same way. People don't want to reinvent the wheel, or the widget in this case. And so there are places you can go where I don't want to redo a shopping cart. I want to that's been done before. I want to use someone else's shopping cart that's really vetted and used and everybody likes, and I could just pull that in and I'm done. So yeah, I think a lot of people don't think of software in those terms. And hardware, maybe even the same way. And I want to talk just briefly. I know we're going to talk about software, but before we get full blown into software, what about the notion of an H-bomb? I don't mean hydrogen bomb, but I mean like a hardware bill of materials, but like for computer hardware or IoT in particular, for example. There's been a lot of cybersecurity vulnerabilities related to versions of chips or electronic components that are in devices. There was that really splashy Bloomberg article a few years back about the little rice of grain sized chip that was supposedly, compromising all these motherboards. Is there also a notion of hardware bill of materials for computer hardware and IoT?
This is something that a lot of folks are working on, because you're exactly right. It's one thing to say, what can I track the software, but hardware is in some ways almost more insidious because I can't change my hardware. I can update my software, but I can't change my hardware. There are a couple of things that are different about them. First, it is much easier to attack the software layer than the hardware layer. And so as you think about what we need to defend, we sort of prioritize the software side to attack the hardware level, especially at scale, right? I want to attack everything. It gets much harder to do.
Yeah.
Whereas software is something that is easier to do. The second notion gets to why hardware is in fact a little harder is software has certain digital properties, one of which is I can create a mathematical fingerprint of what my software looks like, called a cryptographic hash.
Yeah.
It's harder to take that out of hardware. So, right, my advanced chips have a certain amount of built-in trust. And in fact, there's been a lot of work over the last 20 years to build trust into hardware for large chips.
Right, yeah.
But that's a little different than saying, I've been able to add something to your hardware. So one of our goals that's relevant for national security is let's think about smart meters. Right? We know that we're going to have a smarter grid that allows us to, in addition to measuring energy that's coming off the grid, saying, oh, we want to encourage people to use solar power or wind power, and so they can put power back on the grid. So we need smart meters. And someone may test, say, okay, is this smart meter secure? So they give it to some experts to say, yes, we've done all sorts of testing and analysis, and we've tried to break it, we've tried to attack it. So this first meter that we looked at is great. How do we show that the 10,000th meter that gets delivered is the same one that we actually tested?
Right,
now, there are a lot of folks thinking about that, but that's a slightly different problem than showing that the software is the same. Because again, if I'm curious or if I want to, I can just say, hey, you know what? If I don't trust the software, I'll just put software back on it. I can change it. I can update it. I can revert it back to factory settings.
Right. Yeah, those are excellent points. Very interesting. On a very practical level, on a concrete level, what does this actually look like? Let's start with from a human perspective. Like if I was a human reviewing an SBOM, I say, send me the PDF of the SBOM for Microsoft Word or whatever it is, software I want to evaluate. What source of information would it contain? Like how would it be organized? And ultimately, for people, like who would be the audience for such a thing?
So even before we think about it from a data, we can think about it as a picture. So we can think about it as a tree, where the main trunk is this piece of software, an application. We'll call it Acme application.
Okay.
And so the first two branches, we'll call it Bingo Buffer and Bob's Browser. So our Acme application has two dependencies, right? There are two components that were used in my Acme application. And now let's suppose that Bob's Browser, in turn, uses a component called Carol's compression engine. So now we have a tree that starts with Acme application that's got two dependencies, and then one of the dependencies has a further dependency. And you can imagine that for a modern device, something that's going to have operating systems and encryption and lots of functionality, to be many, many layers deep and many, many branches across. So it's going to be a very big tree. For each of those nodes in our tree, or each junction where we've got a little circle in my head, you draw a little circle. We need some basic information, which is what's the name of the component, who's the supplier, right? What company did it come from, or if it's open source, where can we find it? What version is it? Because as we upgrade things, we need to know, is it up to date or is it old? And then again, we talked about hashes, or what's the mathematical fingerprint, so that if I say I'm using Carol's compression engine and you say that you're using Carol's compression engine, we can know that we're using the same version or the exact same bits mathematically. And then where did this data come from, right? Did it come from the supplier? Did it come from someplace further upstream? Or did it come from, a third-party security company whose job it is to build these? And there's some more data that we may want, but really that's the core of saying that. Now, obviously, if we're having that data in in a form, it's going to look something maybe, right? The naive way is to think about it as a spreadsheet.
Mm.
So here's just the list, and for each of
Right.
these, I want this kind of data. And how you could use that in a very simple thing is I just, search, right? So I have this data, it's sitting on my network, and then, I hear on the radio that we found a new vulnerability. And so now I just search through this data to say, hey, do I have this in this product? But of course, doing that by hand takes a lot of time.
Yeah.
And one of the things that we know we're going to need for security is we're going to need, if the good guys are going to be able to compete with the bad guys, they're going to have to take advantage of the power of automation. And so that's why we're trying to get this to a machine readable approach.
Right, which is perfect segue into my next question, which is this obviously would be a lot more powerful if it was exchanged by machines and monitored by machines and manipulated by machines. So how does it work at that level? Like, how might other computers or other applications or devices, like how do they gain access to this? Is every piece of software queryable, like on the fly? Like, if I have an antivirus software on my computer, is it going to be able to query all the software on my computer and come back with a list of all the components in it and let me know if something is out of whack? Or so at a machine level, I assume it's a much more powerful tool at that point. What can we expect in that regard?
There are a couple of things when we think about it machine readable. So first, it's got to be parsable by a computer. So the computer has to automatically be able to interpret different things. So that's okay. We have some data formats that can use that. And there are some, it's called encoding, either XML or JSON, which allows us to sort of say, hey, this is how this data is streamed. Mm-hmm. But there's another component question buried in your question, which is, hey, how does the data actually get to the person who needs it?
Right.
And I think this gets to some of the complexity around SBOM, because what we're talking about is really saying this has to apply for all software.
Right.
And different types of software. So if it's traditional, right, it's an enterprise application that's sitting on my computer on a server. Well, that's pretty straightforward, right? If I have, right, what is software when it's sitting on a computer? Well, it's just a bunch of bits that's sitting on a drive somewhere. So I can just keep the metadata next to that. And then, I've got a piece of software that's scanning, looking for vulnerabilities. And this is something that almost every business has today, which is vulnerability management software. Is this vulnerable? So now they can say, not just is this piece of software vulnerable, but are the ingredients vulnerable?
Right.
But it's a little different if, for example, we have an embedded system. So if we're talking about what's on a medical device,
right,
well, I may not want my scanner running around on my hospital room network, right? That's a little blinking box that's keeping someone alive. I don't want to just poke at it.
Right.
And so we have some other options to sort of say, how can the data get there? Maybe it will live on a website that's queryable. Maybe the device will have a pointer to say, hey, if you want this, go here. Mm-hmm. And similarly, for cloud-based applications, we have a similar approach where we're saying, hey, you're going to sort of query the online service to say, please tell me what this is. And even that gets complicated because a lot of modern applications, they're quite dynamic.
Yeah.
So they, people may change what's in a popular application once a day, several times a day.
Right. Yeah.
We talk about an hourly build. And so it makes sense to have the data be queryable rather than, having a pull model where I go and get it rather than a push model where someone gets it.
Okay. So it seems to me that I think we are smart enough to come up with plans for how to do everything we've talked about so far. But it seems to be the real problem here, the real bump in the road is we need some agreed upon standards, and we have to get all these other companies to comply. The case you laid out with Acme and the browser and Carol, Bob's browser, so Acme knows they bought Bob's browser. But for you to go all the way down to the leaves of your tree, every single component along there from every single manufacturer of that software has to participate in this. And each of those individual companies needs to be able to trace all the way down to those leaves so that they can make it available, I guess, or maybe there's some sort of recursion that goes on that allows you to each hop try to get the next thing. But how in the world? I mean, we can't even get companies to pick a common numbering format for software. I mean, a lot of them do the X.Y.Z format, but I mean, look at Microsoft Office and Microsoft Windows. They don't use that format. Everyone chooses their own. How could we possibly hope to find any kind of a consensus on an SBOM standard?
So there are a couple of things that we're trying to help the community converge on. And a big part of this effort is to say, rather than try to create a brand new standard, because we want to build on what folks are already doing, it's trying to accommodate the diversity of the software world and rely on computers to do some of the last mile interpretation we have to. So for example, we have data formats that can convey SBOM data already. Two in particular, SPDX, which comes out of Linux Foundation, has been used for years to think about software license information. And then there's a newer standard called Cyclone DX, which is particularly popular for folks who are doing some online web applications. It comes out of the web application world. So we have some standards there, and people are already doing this. And there are some other areas where we need consensus. So for example, versioning we know is never going to be perfect because everyone's going to do it slightly differently. But what we can do is say, hey, for these particular communities, this is how we'll agree, because essentially different communities have their own practices, even if they're not widely distributed. And so for your example of how do we get everyone along the way to actually record this, well, there are a couple of benefits. One is a lot of this is what we call a write once problem, which is we need an organization or whoever's developing the software to commit to doing some of the basics, and the rest will happen automatically. So the first person that says, hey, what's in this component? Well, they only have to do that once, and then everyone else who does that, who uses that component, can take advantage of that data. Second, a lot of this stuff, the software that we use and reuse today is open source. It's developed by the community, so anyone can use it, which again means that because it tends to be more transparent. And so we have some visibility into this. So once we hit open source, then it's a little bit of effort to get the data, but it has the similar approach to being one size fits all. And third, we think there's value in partial transparency. In knowing a little bit about what you have isn't as good as knowing everything, but it's still better than knowing nothing. And so, one of the analogies I use is sort of the and natural flavoring side of things, where folks can say, you know what, I'm going to tell you some of what's in here, but I'm not going to tell you all of what's in there.
Right. That was a perfect analogy. I knew exactly where you were coming from as soon as you said that. So, all right. So the NTIA is, as you said, it's not a regulatory body, and it's not in the role of enforcement. From a business standpoint, how can we bring about the wide adoption of software bill of materials? What are the financial or market incentives for companies to spend time and effort on this? Because there is definite time and effort behind doing this.
There is, but I think a lot of it is data that we have. And one way to sort of flip this question around is if you're someone who buys software, and especially, I think the focus here really is on sort of enterprise customers, not, individual consumers. But if you're going to buy software, if you're going to put something on your network, would you be comfortable with software with a supplier that couldn't generate this data? What does it say if someone can't do this? And I'll go even a little further, that this is the natural output of a lot of software development tools. So I'm going to date myself a little bit by saying this is sort of an extra line in a make file. I don't think the kids today use make files.
But some still do, but yeah.
So that's one approach, is to say here, and let's integrate this into the tools that we're using to build software. The other approach that we've tried to do at NTIA is to really frame this as a market solution. And I think part of that is to say, hey, why don't we have this today? We don't have this because it's a chicken and egg problem. No one asks, so no one offers. No one offers, so no one asks. So what we've tried to do is bring together both sides of the market and help people who use software, especially in certain areas of critical infrastructure, realize that there are benefits to start asking for it. And we're starting to see this in some sectors. So for example, there's an organization called the Edison Electric Institute, which is a trade association of power generation utilities in the United States. And they've issued some guidance that says, hey, we think people, when they buy new advanced systems for utilities should start asking for SBOMs from the manufacturers. And then the manufacturers have to say, hey, wait. When you say you want an SBOM, what do you mean? And then the buyers can say, all right, well, we want this and this. And then we can start to the ball rolling to sort of have some market-driven behavior. And I will also acknowledge that government's going to government. My background is as a computer scientist, but my PhD is actually in economics or applied economics. And so I like it when we can talk about the free market, but we also acknowledge that, forcing functions do help.
Yeah.
So for example, the regulator for medical devices in the United States, the FDA, has publicly said we're going to start requiring new medical devices to have SBOMs.
Oh, wonderful.
And that has really brought the medical device community to the table to say, oh yeah, we want to learn how to do this. And the great effect here is we've also got hospitals have come to the table, ones that actually have the luxury of having security teams, to say, how could we use this data? And so hospitals have been partnering with medical device manufacturers to walk through not just what does it mean to generate SBOM data, but how do we use this in a constructive fashion to actually defend our networks? It's not just transparency for its own sake. We're actually getting better situational awareness and better security.
I was listening to something maybe it was another show you were on where you actually, I think, mentioned a particular case of a vendor who, if buying software products from a company who could not produce an SBOM, they actually charged more somehow, because basically they assumed that the cost of ownership for them would be higher because it would be harder for them to maintain or something. Can you elaborate on that story?
Sure. This is a story it was told by a guy named Sunil Yu, who was a security expert for Bank of America for a while.
Mm-hmm.
And he would say, hey, can you give me an SBOM? And the goal wasn't necessarily just to have the data, but he knew that if the company that was selling the SBOM couldn't generate one, it meant the quality of the software that they were using and more importantly, the process that they were using to generate the software lacked the quality level and the craftsmanship so that their expected cost of using that software over time. And again, for enterprise software, you have to actually maintain it. You have to sort of work with support contracts. There's going to be downtime and things like that. And they knew it was going to be more expensive over time. And so they would take off the asking price. They would say 5%, 10% off the asking price, which directly affects the bottom line, right? If you're trying to sell software, especially to a big fancy bank, you want to make some money. And this was a way of communicating this that was actually based on his experience from a return on investment approach.
Yeah, I thought that was a really interesting example. It's sort of an indicator of software maturity from the company that you're buying from. And if you lack the indicator, then I think it's safe to say that it's going to cost you more to maintain and what. So yeah, that is another, I think, a great example of how the regular financial incentives, especially once this becomes a little more popular, can drive this without regulation. So yeah, I thought that was fascinating.
And I think we're also going to start to see, as someone's looking to buy software, if you have two suppliers, and one can't generate this and the other one can, there are other considerations, right? Features and cost and things like that, right? We've known that security isn't the only determinant in software for a long time. But again, what does it say about the supplier that they can't generate this data and that they're not as diligent about it? And then the other thing this is going to enable for organizations that care about the resilience of their software is to say, well, once I have the SBOM, if I'm going to examine it before I buy it, I can now, if I have two suppliers who have SBOMs, I can now look upstream and say, hey, are they using, up-to-date software? Or even, are they using software that's sourced from organizations that have good reputations?
Mm-hmm.
And there's a fun counterintuitive story I like to tell where if you're trying to choose between two software products and one of them has a bunch of declared security vulnerabilities where it's sort of they've published, hey, here's the flaw in our product, here's the fix, and the other one never has any.
Mm-hmm.
Which one would you choose? And a lot of us might say, well, I'll choose the one that doesn't have security flaws because it's going to be better security. But almost all software has security flaws.
Oh, yeah. Mm-hmm.
And what you want is you want to work with an organization that has the ability to receive, hey, there's a security flaw, and fix, because that gives us that resilience that we need in security. You're never going to be perfect, but what you can do is say, let me build the infrastructure and the muscle memory to quickly respond to security flaws and to quickly push out a patch.
Yeah, it's like it's quiet. It's too quiet.
Yeah.
Right. Just because they're not there doesn't mean they're not out to get you. So, all right. One other potential issue I see with this becoming widely adopted is, particularly for public companies. For private companies, wouldn't the inherent transparency of a software bill of materials be a threat to the intellectual property for some of these companies? I mean, couldn't if I publish completely everything that goes into making my product, couldn't that expose proprietary information? Wouldn't that be a reason why some companies might shy away from doing this?
I think it depends a lot on what aspect we're thinking about, right? The vast majority of software that's simply nothing is magical. No one cares that you're using libc. Moreover, for a large amount of open source, you have to tell people what you have because of the requirements of open source licensing. For example, if you go into your iPhone today, it will have a list of all of the software open source components that are on your iPhone. So a lot of the data is already out there. We want to do what we want to do is to be able to track the version so that you have it up to date and have a little bit of assurance against it. And the last thing, if we go back to the and natural flavorings idea, one, a list of ingredients is not a recipe, right? So people still buy Coke and buy Oreos, even though they have, the list of ingredients on them,
right?
Because there's a difference between saying this is what I'm including versus this is exactly how to assemble it. But if you go back to the idea that we're intentionally designing this to allow for incomplete information so that someone can say, I am including, flour, butter, sugar, and natural flavorings. And now by telling you explicitly that there's things I'm not telling you, you as the buyer can do some due diligence. You can say, well, okay, you don't have to tell me what the natural flavorings are, but you have to tell me if there are known allergies. Or you can say, I'm going to change my contract. So if anything in the natural flavorings does end up harming me, you have certain obligations, right? We can now work with this idea because we're creating a more transparency in the marketplace, and we can actually build from that.
Gotcha. Yeah, that's great points. All right, I hate to keep playing devil's advocate, but so I've been a software engineer for almost 28 years. Even at some really big, deep-pocketed companies with lots of processes and tools and big budgets to do things like this. And even we, at some of these bigger companies, had a really hard time coming up with all the processes and tools. Some of them were kind of internal. I'm sure that at this point, maybe there are some third parties where you could buy some better ones to do this. And as you mentioned, some of the common build practices now actually have this built in. But nevertheless, we were an agile shop. We turned, as you mentioned, and it's not a joke, we were turning out software by the hour. Every single piece of code change that went in, as soon as it went in, got compiled and tested and potentially shipped. And, the makeup of that software could change daily, hourly. Given that, is your team also working on proposals to, about how you generate and manage these things? And what level of confidence do we really have in the accuracy of this information? Like I said, I've worked at big companies, and we tried hard at getting these things right, and even then, it was still quite difficult.
And one of the ironies is at large companies, this is often harder than small companies. That's
Yeah.
rare for security, by the way. Right? A lot of things in security are seen as a bit of an extra tax on smaller businesses.
Mm.
Whereas I think this is one of those areas where a giant company that's going to have 8 different divisions with all these different product families, they each have their own internal management structure. It's going to be hard to develop a single solution. It's going to be expensive because they're going to have to break down those silos. But let's talk about first, how do we generate the data, and then the confidence in this data. So at its core, you cannot build software without knowing which parts you're building software with. Now, we can dive into the complexities of compilers and hermetic builds and all sorts of, we can nerd out on that front. But I think rather than driving down that rabbit hole, let's just say, hey, the goal is to have the computers do the work for us. And every time I compile, my computer, as it builds the software, is saying, I use this building block and this building block and this building block. And so, yes, there is going to be some potential cost to say, all right, I need to explicitly document what the building block is, and I need to sort of write some internal database references so that I'm tracking it. And again, I take the internal database reference and then spit it out in one of these data formats that we talked about, that is, national or international standard. Mm-hmm. But again, that's a write once cost. And that's the joy of software, is moving data around isn't that hard. There are some complexities, but it's not that hard. And so the next question is, well, how do I trust the data? And we've got some complexities there. So if it's coming from my tools, then it's unclear what the source of error would be. Right. At its core, we can think of this as keeping honest people honest. Right. So I'm giving you this. The good news is there are actually tools that can test this. There's a whole market of software composition analysis or source composition analysis, where companies will sort of scan what's in my software. And they have to do this because they have to comply with licenses that we've talked about, or other people have security requirements. And we're starting to see niche targets where people are doing this explicitly for IoT, or explicitly for industrial control systems, or explicitly for medical devices, or explicitly for containers that are built in the cloud. Yeah. So we have more tools that are out there. So even if you can't generate it yourself, someone else can generate it for you. You can pay, or you can generate it and then pay someone to validate it. So we have the ways of doing this. Now, the final question is, well, what about an attacker that's trying to take this data? Well, so one, we have some cryptography to sort of help maintain data integrity over time. So, just showing, hey, the data that I sent is the same that you got there. We know how to do that for other types of things, right? If I sign my code, right? So if I give you software, you trust that software, I can also use the same mechanism so that you trust the metadata I'm giving you about the software. And the final question is, what about really advanced adversaries? So we have the famous attack on SolarWinds, where the bad guys didn't go after the software, they went after the tools. Right. And that's really where we need to go in the longer term, which is to say, we need to have a whole cryptographically supported chain of trust for our entire tool system. We're going to get there. And there are already a couple of very advanced companies and advanced projects that can do things like this today. But right now, we're just struggling to make sure that, my insulin pump is something that has no known vulnerabilities. And, let's solve that problem today, which we can. And down the road, we'll make sure that, we can actually trust the overall software tools. But today, let's say for the tools that we can trust, or for, if we're just trying to make sure that we're not accidentally putting vulnerabilities in the ecosystem, and we'll work towards detecting and ultimately preventing these longer term attacks.
Gotcha. Okay, so we've kind of off the cuff mentioned this term open source software, OSS, several times. I've mentioned it actually many times on the show myself without probably properly defining it, but it's kind of a key to some of the things we're talking about here. So could you maybe take a stab at explaining what we mean when we say open source software, and like how prevalent is the use of OSS today?
So first, I'm going to beg forgiveness from my friends who are active in the open source community, because there are probably a lot of great references and formal definitions out there. But really, open source has transformed the software world. And I came of age as a geek in the late 90s, where I knew people who on the internet would write Microsoft with a little $sign in it.
Right.
And Microsoft was going around saying open source will destroy commercial software.
Yeah, that's
And
right.
that part was wrong, but open source won. So open source you can just think of as projects that are public, that allow anyone to use it according to a certain set of licenses, and where the contributors are nominally a much broader community. And so folks can sort of see the development, see the history, and use it in a much more flexible fashion. If you have a better definition, then please chime in, or if there's anything I left out before we sort of dive into the SBOM side of things. Anything I left out in the definition?
The only analogy I would make is it's sort of like Wikipedia for software. And, when Wikipedia first came out, people were like, who is going to take the time to write encyclopedic entries on various topics and give it away for free? And yet, it's a massive success, just like OSS.
No, I think that's right. And we trust Wikipedia, not because there's something magical about it, but because the likelihood that someone would be able to get away with a long-term approach of contributing false information it's not, right? There are tons of examples out there, but we tend to find them over time. As more and more people look at things and use things, they're going to have an approach. Now, almost every major software company out there today uses open source and contributes to open source. Mm-hmm. So it is something that is actively part of that. And I think that needs to be part of how we understand our software ecosystem. So for example, I was talking to the head of product security of one of the largest software companies in the world. And he said that, and he's good at his job. And one of the things that he does is keep data. And he said, 5 or 10 years ago, the majority of the problems that his team, which their job is to fix security flaws made by the rest of his company. And he said, 5 or 10 years ago, the flaws that they were fixing, the security bugs they were addressing, were written by their engineers internally. Whereas the vast majority of his effort and his team's effort today is in dealing with some of the security flaws that came from their open source ingredients.
And and I brought this up myself, and maybe it's a facile argument to make, but the idea, at least on paper, the idea of that open source software is quote unquote better, is that it's like it's open kimono. Anybody at any point can go and review that code, and with the idea or supposition being that people do, and smart people do, and they go and they pick through that code and they make sure that there's fewer bugs, or perhaps even make sure there's no malicious code, buried in this open source software, because it's wide open like Wikipedia. Anybody can go and look at the internals and review it at any time. And yet there have been some spectacular failures in open source projects. Some of the most common crucial elements like OpenSSL, which is, SSL Secure Sockets Library. That is what is behind HTTPS and a lot of the encrypted communications that we have, and creating hashes for that matter, has had bugs in it. And some of the ones that were found have been there for years. The Bash shell, the Linux kernel, again, these are common things that are used everywhere. So on the whole, what do you think then of the argument that one of the benefits to open source software is that on the whole it should be less buggy and not contain malicious code?
I'm very sympathetic to that. In fact, I've talked to folks, for example, who are in the national security community, especially in the older generation, that are sort of suspicious. Well, this could come from anywhere. Like, yeah, but I also know the sort of people who write software for contractors and subcontractors, and I'll take the sort of open source over the fact that someone's going to write code flaws. But there are some challenges, right? There are going to be flaws out there. And there are a couple of challenges with open source, which is one, if there is a flaw in a major piece of commercial software that we depend on, today we've learned It took us 20 years to realize that we should have automatic updates, right?
Yeah.
My operating system, my phone, Microsoft products, they automate. There's a flaw, we fixed it. Whereas in the open source world, it's not always obvious. And there are tools that help with this. So for example, a lot of the online development tools will tell you, hey, your underlying component is vulnerable. But also we have a certain amount of risk for thinking about things. So one of my favorite stories is not the high profile risk from something like the Heartbleed vulnerability back in 2014 with OpenSSL.
Yeah.
Because, although again, there are still pieces of software that are using that version unpatched.
Right.
But it's a story of something called LeftPad. So LeftPad is part of an online web application system. And it was a very, very simple piece of code, which basically said, hey, if you've got an array, you've got a list of things, and you just want to fill the rest of it with zeros. So I've got a little bit of value and I want to fill zero. One of the easiest lightweight pieces of code out there. But software people like to, don't reinvent the wheel. So if someone's written something, you use it. So this little thing was used in some of the pieces that were some of the most important parts of the web infrastructure. And then the maintainer of LeftPad got really annoyed one day. And the maintainer said, you know what? I'm taking all of my software off this online repository, took it out of Node. And so overnight, really one keystroke, a whole bunch of very important web infrastructure broke because they lost this. And so one of the challenges that we have in open source is a lack of, we don't have visibility into our resiliency. We don't necessarily know what we have. And this is tying this back to SBOM. This allows people to say, hey, my project or this piece of software that I'm using, how dependent is it and how many people are maintaining it? Because one of the core aspects of open source is it needs to be maintained, right? All software, as the world changes and as the rest of software changes, pieces of software can stop working.
Yeah.
And how much of my source, what's in my product or what's on my network, is has an active developer community where there's 6 or 8 or 20 people that are all working on it, and how much of it is what I call the ukulele problem, which is how much is dependent on a single person never realizing that playing the ukulele is a lot more fun than maintaining open source software. and right, this is the sort of thing, especially as we think about critical infrastructure, we need better visibility into not just the security of our software, but the long-term stability of our software.
Yeah, that's funny. We've talked almost exclusively so far about security, or maybe quality, but cybersecurity in particular. But what about the privacy implications? For example, I've seen several stories of mobile apps in particular, it seems, where these apps were caught by some third party, usually, extracting all sorts of personal information and shipping it off to God knows where. Like actually, they would report that this and this and this app are sending data back to someplace in China. And it turns out that this was all because these various app developers all used some common widget software library, something, maybe it was a shopping cart, maybe, who knows, maybe it was pad left, the type of thing where it's a simple thing, but instead of reinventing the wheel, oh, this guy already does it, let me just use that. Oh, it's free. Let me definitely use that. And so, what they end up finding is that there was some common software library that they were using, that the reason it was free is because the shady source of that software library had ulterior motives. And a lot of times the app developers weren't even aware, because maybe it was a tertiary thing. Maybe it was not the thing that they included, but something that included. So I'm also kind of hoping, I guess, that SBOM will help in that regard. What's your take on that?
I think this is going to take us in that direction, where we can actually start to better detect things. And what I love about SBOM is it allows us to, I keep using the term resiliency, it allows us to recover faster. So once we have these concerns where people say, hey, this is bad, or you're using this outdated version that's allowed data theft, or, this web plugin has been taken over by someone who's using it in a way to harvest consumer data. Today, we don't really have the ability to detect that as easily and to recover as quickly. And now, as we sort of push SBOM out into the ecosystem, more and more people have that ability and also can be held accountable if they don't act on that information. And so I think this is going to be something that's really useful. And one other example of sort of the interaction between security and privacy is where SBOM really could have helped is the Equifax data breach, which affected almost everyone in the United States
right.
Who was involved in this. And a large part of that data breach was Equifax was using a known vulnerable platform,
right. Yep.
Adobe Struts 2.
Yep.
But the way they were using it was not easily detected by what they had for their internal scanner, because it didn't sort of look at the dependency of the dependency.
Right.
And so SBOM can really allow us to prevent that kind of breach as well.
One other aspect to this that I'd like to get your opinion on is, because everything's networked, we have so many services in the cloud, we have all these IoT devices, and all these things are running software that they like to talk to each other in various ways. They have these built-in programming interfaces, and we like to call them application programming interfaces, APIs, that basically, they're published usually, sometimes they're not, but they allow software devices to talk to each other and to access functionality over the internet, or maybe even just over your local home network. Does SBOM also address that in any way, like these public APIs? Is there a way that documenting those sorts of interfaces might fall under this as well?
We are slowly working to better understand how this plays with what we might think of as the cloud or the software as a service side of things.
Right, yeah.
Because there are some real differences between how the software is manifest. And I think one of the key aspects is, what do we need the data for? And who's going to be using the data? So if it's about software on my network, then I need to know what's there, because if someone's trying to attack my network, they'll attack the software that's on my network. Mm-hmm. Whereas if I'm using a SaaS product or a cloud product, well, there are certain assumptions, true or not, about whose responsibility it is to protect those networks. And so, one of the easiest questions, hey, what could Salesforce or Google tell me that would help me make a risk-based decision, the same way that if I had a software that were, an embedded system would change. So that's one question we're actively working out. This is one of the joys of developing new practices that are both technical and operational and related to business, is saying, hey, we've got to figure out how this applies in this context and that context. And that's one of the things we're working on today.
All right, so let's put on the rose-colored glasses now. I've been beating you up with a lot of devil's advocate questions, but so let's say we pull this off. Let's say you pull this off. You guys manage to convince everybody that this is worth doing, and it starts happening, and then starts growing and spreading, and we start implementing this on a broader basis. What doors does this open? What is the idyllic utopian future? What sort of innovation could we really expect to see enabled by SBOM once this becomes a reality?
I think the easiest thing is to say, hey, whenever we find a new vulnerability, we'll be able to respond a lot faster. Or, whether it is this was accidental or we've discovered someone that's actively tried to harm people through this. So we'll be able to respond a lot faster. But ultimately, I think this is going to drive a better and more healthy software ecosystem, where we'll be able to say, here we can reward suppliers and open source projects for taking care of their software supply chains and better curating their components, because folks will be able to see this. It also will allow us to do more targeted security. So if I say, hey, in my critical 5G software-based infrastructure, for example, here are the 10,000 components that I have. Well, now on top of that, we can say of those 10,000 components, these 500 are the ones that if anyone could subvert, then they could take over our national 5G infrastructure. So now what we can do is we can watch those components. So it'll allow us to have a better, more efficient investment in security. Rather than saying I have to secure everything, we can do that. Now, that isn't a direct result of SBOM, or rather an exclusive result of SBOM, but it's a necessary condition. So, right, we talk about necessary but not sufficient. So what I want to do is create the data infrastructure layer through SBOM. And then once we have that, I think it's really going to allow a lot of generation and innovation. And this is one of the things that I'm really excited about, is we're already seeing companies today that are basing their business models on helping people produce SBOMs and helping people use SBOMs. And ultimately, you know, I'm from the Department of Commerce. We know that the security that we need is going to come from innovation in the tech sector, in the software sector, in the security sector. And what we want to do is create this common platform that allows people to innovate.
Well, I'll tell you what when I read about this, one of the things is, you know, and my audience is more lay people, and we've talked a lot about enterprise and, you know, big companies and organizations using this. But what I would love to see come out of something like this effort is, I want to get a special home router or put a box on my home network that will monitor all the stuff. I mean, if I look at the number of IP addresses that my router's coughing up in my house, there's dozens, literally dozens of internet connected things in my house. You know, now I try to put the ones I trust least, you know, on my guest network, but nevertheless, I would love to have a tool sitting in my network that can monitor those things and realize what software is running on those things, including the piece parts of that may be vulnerable, and be able to alert me, hey, there's a new CVE out, there's a new bug against, you know, OpenSSL version, blah, blah, blah. And oh, by the way, you've got 4 devices in your house that are currently using that and need to be updated. I would love to have something like that for home users. Because, I mean, yes, you're right. We absolutely need devices that update themselves. And hopefully that may require regulation. We need to have that happen, because I read an article, I think just this week, that said that the bad guys had gotten to the point where as soon as a patch is pushed out, they, within minutes, have developed software to probe for and violate those vulnerabilities. And that means that anybody out there who has not updated their software on something, it's going to be vulnerable immediately. So yeah, anything that could help the average person automate that process, I think would just be phenomenal.
And that's right. The automation for this level requires a number of different steps. And that's really what we're trying to do, is help these different parts work together. We've tried to build SBOM to follow sort of a modular architecture principle, which is to say, once you have it, let other people innovate on top of it and around it so that they can build more things. Yep.
All right. Well, as we wrap up here, where do things stand right now with this initiative? You said it's been around for a while, and you're kind of herding the cats around this. But you know, where does this SBOM initiative stand, and, you know, like, what might we look for in the near future? And one more follow-up: what standards bodies or organizations or companies are out there helping to lead the charge with this?
Right now, we actually have almost too many organizations to name that have been playing a leadership role. I've mentioned the data formats of SPDX, which is built by the Linux Foundation, and CycloneDX, which is adjacent to an organization called OWASP. Both of those have been moving forward to sort of promote them as standards. But the exciting news about what's happening in SBOM is, in addition to having the community of champions work towards this and having people from industry think they need it, this was featured in the administration's recent executive order, which came out 2 weeks ago at the time of recording, saying, one, they actually offered a definition of SBOM. So it's now something that we have at the highest level of policy. And that definition is built not just to say, it uses the list of ingredients analogy, but it also talks about its value. It defines it by what we can do with SBOM. And it has directed NTIA, my agency, to define the minimum elements of SBOM. And so we're now going to see this as something that is going to be fitting into higher level government policy. Ultimately, the goal of the executive order is to use the government's power of the purse to say the software that the government buys will have security features, including a range of issues, such as having more secure development practices, and, you know, having companies that develop software need to have things like multi-factor authentication. I am confident that all of your listeners use multi-factor authentication, especially for their email. But if you don't, please do so.
Yes.
But to say ultimately everything the US government buys will have an SBOM. And we're going to be spending the next few months and maybe even longer talking about exactly what that means, because once you put something into regulation, you need to be pretty precise.
Yeah.
And so the challenge is going to be how to navigate enough precision while still allowing flexibility for different circumstances and types of software and use cases. So that's the good news, is we are doing this. Like, this is going to happen. And while that's happening, we're going to be continuing to help the community make sure this scales and make sure this is data that doesn't just say, hey, give me the data, but making sure that it is commonly interpretable and can be used across large organizations so that it's cheaper and easier to do.
Well, I cannot wait to see it. I'm looking forward to seeing those proposals when they come out. Last question. What recommendations do you have for people that might want to learn more about this or, potentially even help to drive the adoption of these proposals?
We would love help. One of the joys of this effort is we've had experts from all across the community, from around the world. There's one guy who's got a one-person software company in upstate New York in the energy sector, and he's very passionate about this. And we're also partnering with governments and agencies around the world. So if you want to get involved, there are a couple of things you can do. NTIA.gov/SBOM will give you the basic information, including an SBOM at a glance document and an FAQ for frequently asked questions, and a lot of the basic information. There's a great conversation happening on Twitter. For those of you who use Twitter, just look up hashtag SBOM, SBOM, and you'll find a lot of the people that are talking about it and building products and engaging. And, there are even people making memes about it, which warms my heart. And feel free to reach out directly to me if this is something that you or your organization would like to learn more about.
Wonderful, wonderful, wonderful. I know it just seems so simple, but transparency is huge, and it's something that's sorely needed. So, Alan, thank you so much for coming on the show and explaining this all to us.
Thanks for having me. Really enjoyed it.
Thanks again to Alan for coming on the show. Really enjoyed that topic. I hope you did too. And I hope you can see that a lot of times it's really just the simple things. I say this over and over, but awareness and transparency, information in general is powerful. And in so many cases, the first step to solutions to a lot of these problems is just being aware of what the problem is and documenting what's really going on. If we had this software bill of materials right now, if all software came with this, and we could immediately see what software was running on all the devices on our network, it would be so much easier to prevent these things from getting hacked when vulnerabilities are inevitably found. So as usual, I captured a little bit of bonus information from Alan, and that will go out as bonus content for my patrons. And even though the coin challenge is still over, you can still join as a patron. And maybe we'll even find a way to get you a coin whenever I do another challenge down the line in the future. I will have you know that I did offer coins to existing patrons when I ran the last one that had been around for a while. So not sure when or really if that'll happen, but it probably will. And if that does come around, I will not leave you out in the cold. Now, something else that we didn't really cover, another aspect to SBOM, or related, maybe it's not strictly a software bill of materials, but another thing we could do, another extension to this idea, and this is actually something I tried to patent at Cisco, and they said, nah, no, we're not interested. In the meantime, I think other people have already done this, and perhaps even at the time others were doing it. But if these same devices, especially these IoT devices that we deploy into our home networks, if there was a way for them to, in a secure fashion, provide a profile for their network activity, that is, they would say, okay, here is where we expect to be making connections. Here's how often we're going to make connections. Here's about how much data we're going to be transferring to or from these IP addresses or these websites. For example, this is where we're going to send, crash reports if something bad happens. This is where we're going to send some telemetry data so we can keep an eye on our products and we know which ones might be misbehaving. We'll send, once a day, we will send a message, with about this much data to this website. They all do this, by the way. You just don't see it because it's all happening behind the scenes. But there is some sort of regular behavior. And if these devices in their software could specify, this is how I act when I'm acting normally, then you could have something in your network who consumes all that and keeps an eye on things. And when all of a sudden your internet-connected toaster starts talking to some new location in China or Russia, or starts sending a lot more data than it used to send, or your webcam is all of a sudden sending data to a new location, it could flag that and say, hey, this device is acting abnormally. You might want to check it out. Anyway, this whole concept is really interesting and has a lot of great applications, and I can't wait to see this stuff start to roll out. All right, so that's it for today. Next week, we've got a news show for you and then an interview after that. And the week after that will be DEF CON. That will be interesting. And I hope to bring as much of that vicariously to you as possible in that special podcast. Take care, everybody. Stay safe out there. And until next week, as always, don't get caught with your drawbridge down.